Hello everyone and welcome to another RICHCODE USACO Bronze video. In this video, I will be going over uh, from the 2015-2016 season Contest 3, February, and Problem 3, Load Balancing. So Farmer John's and cows are all standing at distinct locations, x1, y1, all the way to xn, yn, on this two-dimensional farm. From 1 is less than to n is less than equal to 100, and xi's and yi's are at positive odd integers at most b. And so that just means that they're all standing at least two apart from each other and that they're only up to 100 cows. And Farmer John wants to partition his field by building a long, effectively infinite length north-south fence with equations x equals a. A will be an even integer, and thus ensuring that he will not build a fence to the position of any cow since the x positions and y positions are all odd. He also wants to build a long, effectively infinite length east-west fence with equation y equals b, where b is an even integer. And these two fences cross at the point A, B, and together they partition this field into four regions. So it would be like this, where there are cows here. And so Farmer John wants to choose A and B so the cows appearing in the four resulting regions are reasonably balanced, with no region containing too many cows. Let M be the maximum number of cows appearing in one of the four regions, and Farmer John wants to make M as small as possible, and we need to help him determine the value of B. Now, so in the first five test cases, B is guaranteed to be at most 100. In all test cases, B is guaranteed to be at most 1 million. So for example, if this case that I just drew, the maximum M would be 2, since there are exactly 2 in each quadrant. But if there's a case where, let's say, there are 4 here, and there's 1 here, 1 here, and 1 here. And let's say we did this, then M in this case would be 4, since there are 4 in this region and 1 in every other region. So what exactly comes to mind with this problem directly is to just check all the X and Y's to put A and B at. However, this will be way too slow as 1 million, we would have to check 500,000 X's, and then we would also have to check 500,000 Y's. And multiplying these two together will give us 25 followed by 10 zeros, which is going to time out. So in order to fix that, we're going to need to optimize it. So taking advantage of the fact that there are only effectively 100 cows, we can see the following. If we have a cow, let's say at 1, comma 1, and let's say we have a cow at, let's say, 999, 999,999, 999,999. The answer to this question is 1. If no matter where we draw it, as long as we don't draw it, basically almost any solution works. And from this, we can see if we drew it at, let's say, x equals 999,998 is the same as if we drew it at x equals 2. And it's also the same as if we drew it at x equals 100. So that tells us we do not have to check every single x and y. We only have to check x and y's that actually impact our answer. And the only times that happen is right after or right before cow's location in both the x and y direction. Now we don't have to check all befores and afters as that would just be one act. We could, but it's not needed. Instead, we only have to check afters. And checking afters, since we're never going to want to, if there's a cow here, if we have, let's say, 4 cows, we're never going to want to put one fence on the left of the leftmost cow or below the bottommost cow, because that would just be counterintuitive. So the way to solve this is we need to as we're looking through our cows, we just need to determine Okay, so if it was at xi comma yi, we just need to check all xi plus 1 and yi plus 1. And then after, for each one of them, we can then check if where each cow is and determine m from that there. So let us code this. So first line is n and b. Okay, so we don't exactly care what b is since our solution will work for any size as long as n, if n is around 100, we do not care what the size b is. Okay, so we have an int array the x positions. Okay, now that we have taken an input, we can then declare an array list of the what we should check in the x, and then also one in the y. And then we just insert x pos I and y pos I, both of them added one into them. X dot add. Okay, so now that we have done that, we can just check. So we need to determine the number of cows in each quadrant. Okay, we'll just okay. So then to do that, we would create a int top left equals 0, int top right equals 0, int bot left. Now, we don't exactly care how you define these quadrants as long as we continuously keep the same definition. So then we can go through our cows. So I'll say that if they're both greater than, then I'll increase top right. Else if, and if the x position is greater but the y position is less, then I'll say it's the bottom right. And then if the top left is when x is less than and y is greater, and bottom left is when both of them are less. Okay, now that we've determined what top left, top right, bot left, and bot right are, then we can have a running answer. So int. So we can assume that in worst case scenario, we have to put all 100 cows in one region, and that will be answer. It will never be more than all the cows in one region. Okay. And then so then we can just set ants is to the minimum of the maximum of top left, top right. It's math.min, math.max, and math.max. And doing so, ants math.min. And doing this, so this back part just determines the maximum in each quad in all the quadrants, the maximum of it. And then this just makes sure that we keep it as the find the minimum of it. And then at the end we just output the answer. So print ln. Okay, so now let us submit this. Okay, and I just see this works. Thank you for watching.